So I want to spend some time just playing around with locks, seeing locking and blocking in the default behavior of SQL Server. So in both of these transactions, I'm going to set it to the read committed. That's the default level, just to make sure everything is just fine. And we're both in the CHA2 database, looking pretty good. And notice that this one is SPID number 52, and our second connection is SPID number 53. So let's start out, and within a transaction, I'm using transactions here, by the way, just so that we can hold our locks. So if you say begin transaction and select, then you're going to be able to hold the lock. If you just say select, it's going to grab and drop the lock right away. So just so that we can see the lock. And I will execute. Now there's a tool called the Activity Monitor, and I'll open it using Object Explorer. Down in Management, under the server, there's Activity Monitor. So Activity Monitor will let you see all of the locks that's happening for a specific server. So you find it under a server in the Management node. And I'll open it up. I'll resize this so we can see more columns. There's a couple columns all the way at the end here that I'm interested in, called blocked by and blocking. So I'm going to drag these back. And give us a little more room by closing out a couple of these. There, that's good enough. So we can see, here's 52, here's 53. We're in CHA2 both databases. And right now there's no locking or blocking happening. Let's go back and try some more scenarios. SPID 52 is still inside of a transaction. Let's go ahead and do an update. So because the transaction isolation level is set to read committed, and we just made an update within a transaction, SQL Server will prevent another transaction from seeing this change until we come down and run the commit. And I'm not pressing execute yet, I'm just showing you the commit. So we're in a transaction halfway through. Pop over just to show you. 52 has an open transaction. There we are. Now we'll pop back to SPID 53 and attempt to select it. Execute. And it's now waiting, showing executing query, and this will just spin for hours. So go ahead and get yourself a Coke, make some popcorn, come back. Here we are. It's still spinning. And it's going to continue to do so because SPID 53 is blocked by SPID 52. And we can see this in the Activity Monitor. And I'll hit refresh. And we can see SPID 52 is blocking one other one, and SPID 53 shows an hourglass. It's waiting. Here's its wait type, and it's blocked by SPID 52. Looking at locks by process, you can see that here's the exclusive lock by SPID 52, and because of that, SPID 53 is having to wait. As soon as SPID 52 commits this transaction, you'll see that the lock is released, and SPID 53 can then finish its select, and it comes back with the answer. So, executing now. Bang, there it is. So that's observing the locking and blocking process, and it's a critical reason why many databases have performance problems, is this locking and blocking, because developers are writing programs with long transactions. You want to keep your transactions nice and tight and short.